Hi, let's continue with our section. In this video, I want to talk about some of the basic Pandas operations. So let's write some code for that. So in here, we will use the Google Colab, and of course, we need to run. So to get the connection of the notebook. So let's wait for a bit, and this is connected. And now it's the time to write some code. So we will import Numpy and Pandas modules. So it's very simple. So we need to import Numpy as np, and then we need to import Pandas as pd. So let's run the code for that. And now we will create the Pandas data frame. So let's create that. So we will create a Pandas data frame. And in here, we will use a small data set for our simple example. So data store in a Python dictionary. So now let's write some code for that. So we got data equal open bracket. So we have is docs 23, 17, 5, 12, 1, 5, so docs we have 23, 17, 5, 12, 1, and 5. And then we have bird. So it will be equal to 10, 7, 13, 2, 8, so 10, 7, 13, 2, 8, and 19. So I need to make some space. And the final one is cuts. Is we will have 4, 14, 8, 15, 11, 3. So this is just a simple data set. So of course you can change on these numbers. And then now let's bring data. So we get birds is dog is 23, 17, 5, 12. Bird is this one, 10, 7, 13, 2, 8. So now after that, we will convert. So I need to create a new code cell, and then we need to convert dictionary to a Pandas data frame. So notice that index numbers are serially generated. So we have a shelter equal pd dot data frame. So we put the data in, and then now we have a shelter. And now let's look at. So we have the dogs, bird, and then cats. And then we want to find the information about the data frame. So finding information about the data frame. So it's very simple. We just use the shelter.info. And then let's run. So we'll get all the information in here. So we get dogs is integer, bird and cats is also integer. So we have data type is integer, and we have a memory usage as well. So now let's create a new code cell, and in here we will take a look at the head of the data frame. So in here we have is shelter dot head n equal 3. So we'll look the first 3 rows. So in here we got 23, 10, and then 4. So now let's take a look at the last 5 values, which is detail of the data frame. So we get shelter dot tail. So let's run. So these are last 5 rows of our data frames. So let's create a new code cell, and in here we will create a data frame with index names specified. So we have is data is the data set in dictionary format. So index names are in a list format. So we'll create a index id index names. So equal shell the 0, and then we'll copy comma shelter 1 comma shelter 2 comma shelter 3 comma shelter 4, and then we got a shelter 5. So now we will have a shelter dot index name equal pd dot data frame. So we have data comma index equal idx underscore names, and then we'll have a this should be underscore. So shelter underscore index name pd dot data frame data index equal idx names, and then we just copy and then paste. And as you can see, the number 1, 2, 3, 4, and 5 are replaced with the shelter 0, shelter 1, shelter 2, shelter 3, shelter 4, and shelter 5. So now is your time to talk about how to work with rows and columns. So let's create a new code cell. So we need to select row only by label. So we're using the log method. So dot log refers to label. So now we'll have the shelter index name dot log, which will have a shelter 3 in here. So let's run. So if we have the shelter 3, it will have all the information. So we get dog is drowse, as you can see, bird is 2, and the cat is 15. We also have the name and the data type, which is the integer. So let's create a new code cell, and now we will select row and column using log. So the same thing. So I just copy the code that we just wrote before, comma, and then we got birds. So it will definitely bring, we will have the result is 2, as we have the shelter 3, and we choose the birds in here. So we got birds and shelter 3, so we'll have the number 2. As you can see, we got our really good result. So now we'll talk about the slide by row using index positions. So we'll have a shelter index name. So we'll slide from 2 to 5. So the first one is 0, 0, 1, 0, 1, 2. So we will add 0, 1, 2. So we will start from here, and then 0, 1, 2, 3, 4, and then 5. So we'll have shelter 2 until the shelter 4. So let's run. So as you can see, we got 0, 1, 2 at exactly 3, 4, and then 5. So we got is from 2, 3, and 4. So because we got 1, 2, 3, 4, 5, 6, and then we got the shelter 0 start at the index 0. So it's go from shelter 2 to shelter 4. And now we will slide by row using label names. So we have the values and node index position. So we'll take this value. So we just use the same. So now in here we'll have is shelter 2 to shelter 5. So this one now they will go from 2, 3, 4, and then 5. So we use the label names. This is the difference to the index position. So let's run. So as you can see, we got shelter 2, shelter 3, shelter 4, and shelter 5. Now let's write some new code. So we will select column with slide method and on rows and column at index position 1. So you will get back the bird column, which is index position 1 column wires. So I refers to index. So we get shelter. So I just copy the name over here. So we got shelter index name dot ilog. So everything until to 1, and now let's run. So we get on the bird. So this dog start at 0, bird start at 1. So we got on the birds column. So now we will learn how to select multiple rows and columns with slide method. So similar to Pythonic way of indexing. So we have the same, and now we'll have the ilog 2 to 5 and then 0 to 2. So let's run. So we got the dog and bird, so from 0 to 2, and then we got 2 to 5 here. So now we will select column using the dot notation or bracket. So we'll have a shelter index name dot docs. So we'll choose the docs. It will bring all the information about the docs. So 23, we got all the information about the dog. And now we can select multiple column with brackets. So we'll have is dog, comma, cats. So it will bring all the information about the dog and the cats. And now we can select column names with no parentheses. So in here we have a dot columns. So it will bring on the dog, bird, and then cats, as you can see. And we can sort by value. So we will perform sorting by values. So we will sort underscore values, and then we'll sort by equal to cats. Let's run. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, And now we'll sort on by class. So we got 3, 4, 8, 11. So it's increasing, as you can see. And now we will bring the summary, the statistics. So it's very simple. We just use the describe, and then we will get all the summary. So let's run the cell. As you can see, we got count, mean, standard deviation, mean, and then max. And now we will use the transpose data. So rows will become columns as we transpose it, and columns will become rows. So dot T stand for transpose. So let's run the cell. So we got the dog and the shelter at the top, and then the dog, bird, and then cat here. Before that, we got dog, birds, and then cat at the top. So as you can see, it is transpose. So we'll perform some advanced Pandas operation in the next video. And that is all in this video. So I hope you enjoy it. And I will see you in the next video. Hi, let's continue with our section. And in this video, we will perform some advanced Pandas operation. So let's write some text for that, and we will continue what we have done in the last video notebooks. So advanced Pandas operations. So in here we will demonstrate how to use lambda, apply, map, filter, reduce, and group by. So let's see the data frame again, which shelter names. So in here we got shelter index name. So let's run. And that is our data. So now we will see the use of apply and lambda. So we get shelter index name. So we choose the docs. Equal shelter index name docs, and then we dot apply. So we have is lambda x to x times 17, and of course you can experiment more by changing this number. So I just copy. So we change to bird, and then bird, and then times 8, and then times 23, and then we got cats, and then we got cats. So now we will bring the shelter index name to see what is happening. So as you can see, on the docs is on the values is times by 17, and then the bus is times by 8 and the cat is times by 23. So it actually times on the each individual values in the column and then rows. So that is really good. So in here we will see the use of apply and map. So we will apply a function to a data frame element wise. So we have is shelter index name equals shelter index name dot apply map. So lambda x divided by 2.0, and then we'll have is, so as you can see that is all divided by 2. So we got 391 divided by 2 is 195.5, and then 80 divided by 2 is 40. So that is really good. And all, of course, all the values in here is divided by 2. And now we will see the use of filter with brackets. So where the condition is met, the actual value shows, otherwise it will show order, while it will show n a n, which is not a number. So now we will see where do we have values less than 50. So we'll find all the values which is less than 50. So we have is results filter equal shelter.index name. Shelter.index name is less than 50. And then we will see the result filter. So as you can see, we find all the values less than 50. So we got shelter 0 dogs is larger than 50. Shelter 1 as well. Shelter 2 we got here. And then shelter 3 is larger than 50. So that's why it shows not a number. So let's write some code. So we will see filter, how to filter with query method. So where do we have more than 50 cards? So we have result filter dot query. So we have a cards larger than 30, comma in place equal to true. And then we have is result filter. So it will only have the card is larger than 30. So in here we got 46 and 34. So now we will see the example of summation of column. So we'll get doc underscore sum is equal to shelter index name. So we get is docs dot sum, and then we got dot sums. So we sum all the doc is 535, and now we will display. So we will see, we will display data frame again. So this is our results. So now let's write some code for that. So rows wise operation with axis equals 0 for a numpy array. So we will reduce using apply and np.sum. So we got df underscore sum underscore column. So we got equal to shelter index dot apply. So we have is np dot sum reduce equal true. Axis is equal 0. So there will be some warning. So the reduce argument is deprecated and it will be removed in a future version. So just be careful for that. So and then we get is np dot sums down the rows per column when we set axis is equal to 0. 0 refers to the row axis for a numpy array. So in here, rows wise operation. So we have df sum column equal shelter dot apply np dot sum. So we have axis is equal to 0. And now we got, so it will sum on the docs, bus, and then cast. As you can see, we remove the reduce argument. So let's continue. So we have the column wise operation with axis equal to 1 for a numpy array. So you get back some totals per row. So we have a sum row equal shelter index name dot apply. So we got np.sum, and then axis is equal to 1. So we will sum all the rows together to see. And as you can see, we sum all the rows. So we got the row 1 is shelter 0. In here we sum all the column, and in here we sum all the rows. So now let's continue for that. So we will create a fourth column that has a list of Boolean values. So we got new comma code equal open bracket true, comma true, comma false, comma true, comma false, comma false. So we will assign list to be the new column name. So we have a shelter index. We have is Foster. So these are a random name equal new column. And then we'll bring the shelter index name. So as you can see, we got a fourth column called Foster, and this contains all the true, false value that we already created before. So you can change all these numbers or all these if you want. So the last one we'll use is we will see the use of group by and some aggregate functions. So in here you will attend the aggregate sums across shelter where false or true. So we have is shelter index name dot group by, and then we have is Foster, which is our new column dot sum. So let's see, we have the Foster is empty because it's just use the true or false. So it doesn't have any value in here. So we have the number of false is that for the dogs. So we actually sum all the numbers that is the false by the dog. So we got here, here, and then here. So if we add up them together, it will get 93. And we got bird is on the false here, and then we got cat is on the false, add up together. The same thing for the true. So we got on the true, add up together for the dog. So we got 195.5 plus 144.5, and what else we got 102. And if we add up them together, it will be equal to 442. The same for bird and then cats. And that is all in this video. So I hope you enjoy it, and I will see you in the next video. Hi, let's continue with our section. In this video, I will talk about working with Pandas datetime. So first, we of course need to import Numpy as np. we need to import pandas as PD, and then we need to import datetime library. So let's run the cell to get the connection. And now we will write a big text in here to talk about the basic datetime operation. So let's write the new code cell. So we got date underscore var equal pd dot to underscore datetime open bracket 10/15/2019 comma np dot datetime 64. So we have is 2019 10 and then 15, and after that we have the comma, so we get datetime dot datetime open bracket 2019 comma 10 comma 15. So let's write some comment in this code. So we will be passing time series information from various sources and formats. So we have date underscore var. So if you run, we have is datetime index. So we have 2019 10 15, and then we got 2019 10 15, and we got the same, and then we got the data type is datetime 64. And now let's write some new code cell in here. So we will generate sequences of fixed under. So we got frequency fixed generate sequences of fixed frequency, dates, and time span. So we have is frequency is set to daily. So we have date var equal pd dot date underscore range. So we'll have is 2019 10 and then 15, and of course you can change this number. So in the first one that we change the format in here to become here. So we change this format into this format, and now we will have the comma period equal to 5, and then we got 3 is equal to d. So let's run the cell. So I got the errors because I misspelled the date range. So we'll have the date, the range of the date from the 15 10 2019. So we got 10, we got 15, 16, 17, 18, and 19. So these are the 5 days from the 15 10 2019. So we got the 5, and of course if you change to 6, we will have the 20 over here. So now we will manipulate converting date times with time zone information. So we got is UTC means universal time coordinated world clock time. So we got date var equal date var dot t z localized, and then we got is UTC. So we got date var. So let's run. So as we can see that we got 1500 plus 000, so we all get a 0. So this one is the US. Is we got a UTC, so this is a universal time coordinates. And now we can convert it. So let's convert to Eastern time zone. So now we got dot tz underscore convert, and now we have is US comma, not comma but backslash Eastern. So of course you can change on the time zone to your time zone. So in here I just use the US because this will be easier. So we got a 4, so we convert it into the US time zone so successfully, and now we will resampling or converting a time series to a particular frequency. So we got IDX equal PD dot date range. So we have is 2019 10/01. So we change to periods. Before is 6, now we change to 7. And now we got is frequency. So fresh is equal to D. So this mean date. So of course you can change to S for seconds, and or H for hourly. So we got TS equal PD dot series range, and then we got length IDX comma index is equal to IDX, and now we got TS. So let's run, and we got the result is 0, 1, 2, 3, 4, 5, and then 6. So we got the start date is 0, 1, 10, and then it's increased to 0, 7, and we have the index from 0 to 6. So we actually have the periods of 7, and the index starting is 0. So let's copy this code, and then we can change it to month to see what is happening. And of course, if we increase it to 10, we'll have the 0 to 9. And in here we got 31, 30, 31, 30, 31, 29, 30. And then we got the 10. So we got 10, 11, 12. So as you can see, we increasing. We start at 10, we increase to 11, and then 12, and then we finish the year at the December is the last month, and then we increase from 1, 2, 3, 4, 5, 6, and then 7. So that is really good. And now we'll talk about working with time stamp data. So let's write some code for that. So for Pandas objects, time means using the points in time. So we have is pd dot time stamp, and then we got is date. So we got date time dot date time, and then we will have is 2019, comma 7, comma 15. So if we run, we have the timestamp at this time. So when you create timestamp, notice that hours, minutes, and seconds are included. Even when we did not specify. So we have the pd dot time stamp. So we got is 2021 0808 is the time I recording this course. So let's run. So we got the day, month, year, and then the hour. Because we did not specify, so it will be 0. So time in terms of a span or period. So the span represented by period can be specified explicitly or infer from the time string format. So now we have ed dot period, which will be the 2019 10. So let's run the cell. So we got the month, and we include the date. So let's copy and then paste. So we got free is day. it will have the date in here. So now we can create a list of timestamps. So let's create a list of timestamps. So we got days is equal pd dot timestamp. So we got 2015 05 and then 01, comma. So I just copy the rest so I don't have to type. Set our time. So we got 02 and then we got 03. So we got dates. So let's run the cell. So we got on the list of timestamp in here. And now we will create a pandas series that use the days. So we'll have the random numbers from standard normal distribution. So we get ds equal pd dot series np dot random dot run n 3 comma days, and then we got a ts. So let's run the cell. So it will have the random number. So we got here is 1 2 3, and then we got 1.22, 1.89 and 0.81. So we can verify type of index. So we got type ts dot index. So we got pandas called indexes data frame data index. So we will create periods that are monthly. So we got period equal pd dot period. So we get is 2017 07, and then we just comma and then we continue. So this is a month and this is a year. So 0 8 and then comma we got 09. So let's run. And of course I forgot to bring the periods. So let's run. So we got the period here with the month. And now we can create a pandas series using the periods as index variable. So we got ts equal pd dot series. So we open bracket is np dot random dot run, and then we put the number 3 comma we got the periods So let's run, and we need to have the TS in here. So we got this number, and now you can create the date range with 10 periods. So date is given as what year, month, and then day. So we got days is equal to pd dot day underscore range. So you have a 2019 10/01, and then the periods is equal to 10. So we got the days here. So we'll get 10 days after the 0, 1, 10. So we get 0, 1 until 10. And that is all in this video. So I think this video is a little bit long, and I just stop here, and then we will continue it in the next video, and I will see you in the next video. Hi, let's continue with our section, and this video will converting to datetime. So now we will converting to datetime. So let's create a new code cell. So to convert a series or list like object of date like object, this can be example is string, comma, epoch, or a mixture. So you can use the to underscore datetime function. So we'll have is pd dot to underscore datetime, and then we'll have the pd dot series. So we'll open bracket with the July 09 and then 2019, comma. So now we have it 2019 07 and then 10, and then we got is comma none. So let's run the cell. So it will convert to the, so as you can see, we got July 0919 into the 0907 and then 2019. This one is the same, and this one is none because it doesn't have. So this will output the NAT. So now we will convert days to datetime. So we got a pd dot to underscore datetime, open brackets, and then we'll have a 2005 comma backslash 12 backslash 25 and comma. So we have a 2005 dot 12 dot 31. So let's run the cell, and we got the 2005 12 25 the same. and we got the daytime 64 and frequency is none. So if you use days which start with the day first, so example is European style. You can pass the day first flag. So we have is bd dot to underscore day time. So we'll have is open bracket 0901 2019 10, and then we'll get is day first equal to true. So let's run. So we get is 2019 0109. So it will arrange it 10. And then we just copy this one. So we change the day. So 0201 2017, comma 0103 2018. Of course, we'll keep day first. So we will have the arrangement is 2017 first and then 2018. So the year first and then the month and then the date. So you pass a single string to daytime. It return a single timestamp. Timestamp can also accept string input. So but it does not accept string parsing options like day first or format. So use to underscore daytime. If these are required, so we have is pd dot to underscore daytime. So 2019 10 and then 01. So let's run the cell. So we have is 2019 10:01 with the hour, minutes and seconds. So we don't specify, so that's why this will be 00. And you can see that is convert to the from this one to this one. So you can also use the daytime index constructor directly. So pd dot daytime index, so we'll have is open bracket 2019 01 01 comma 03 and then comma 05. So let's run. So we got all the data on the time. And let's write a new code cell, and in here we got the string infer can be passed in order to set the frequency of the index as the infer frequency upon creation. So we'll have is PD index open bracket square bracket. So you can pass any day. So I just use 2014 0117 comma. So you don't have to use exactly what I'm using the date. You can change it to see what is happening, and I do require you to change it. So it will help you to understand more. 19 and then the comma flag equal to infer. So we get the result 17, 18, 19 daytime, and we got the day. So now we will providing a format argument. So pd dot to underscore day time. So we have a 2019 10 and then we got is 11. So we'll change the format. So the format is equal to percentage year. So it should be year percentage M, and then we got percentage D. So let's run. So pd.to daytime 2019-10 comma format. So I just take a pause and I forgot to do the backslash in here. So that's why it doesn't work. And now we got the result. So now you can also pass a data frame of integer or string columns to assemble into a series of timestamp. So we have is df equal pd dot data frame. So open bracket. So we have the year is 2017, comma 2018, comma 2019, comma. So we got month is 3, 4, 5, and then we got day is 15, 16, and then 17, and then we got is the last one is hour, So we got is 8, 9, 10. And then we'll have is pd.to underscore datetime open bracket df. So let's run. So we have the 2017 315. So 2017 315, and then hour is 8 hour, and we got the margin 2018 416, and then 9 hour. And you can pass only the columns that you need. So we have is pd.to underscore datetime. So open bracket. So we have df. So we got year, comma, month, comma, day. So let's run. And then we got the 2017 315. And now we pull out our data only. So we got df dot hour. So let's run. So we got 8, 9, 10. And then if we do month, we have is 3, 4, 5. And then if we got year, and you can also pull the second. So we can't pull the second. So how about df dot day? See, so you will have the day and in here. And that is all in this video. So I hope you enjoy it and you can successfully run everything in the notebook. So if you have any questions, you can ask me in the Q&A or you can text me and I will come and assist you. And I will see you in the next video.